Well, hello again. This time what we're going to do is do some plating. I noticed Carl on the Healy channel did a video on this just recently, and there's a lot on YouTube about nickel plating. And I've got somewhat the same deal. I've got here 2 nickel plates that I used sometime in the past. I've got welding rods as well, pure nickel welding rods. And the plan is that I had originally painted these fellows with a silver paint, but it's not really that satisfactory, and what I like to do is clean all the paint off and nickel plate them. And I've got the other one that you saw still on the throttle switch, so, and plus I still need to make one. I don't have any 3mm scrap lying around to do it, which seems odd, but I might have to wait a day just to try and pick some up so that I can make another one of these. So what I'm going to do, I happen to have here, and I'll bring you in a little bit closer first, I guess, and so you can see my little voltage supply. And the good thing about this unit is it's a 2.5 amp 0 to 30 volt. Okay, so I can control voltage and current. I've had this for about 1,000,000 years, so I thought, well, let's pull it out and use it. And I've got here also the makings of what we call nickel acetate. Now, Carl explained it as the deterioration of these nickel plates into a solution. Okay, which will, and I've got a nice brand new little bucket for that with a lid, so that when I'm done I can seal that, and yeah, it'll be I can use it again and again. So let's just take a little look around and see what we've got to make up this this solution. So I'll pick you up. Okay, what I've got, as you can see, is just some white vinegar, just 2 litres of white vinegar. I've got some demineralised water. Distilled water is fine, and probably even tap water if you're in a clean area that's got clean tap water. So I just happened to be walking past that in the aisle at the hardware store, and thought I'd just grab that. I was going to get some hydrochloric acid. I do have some here somewhere, but I can't find it, for a wash in between. Well, in between, in other words, a clean up, a quick dip in a very weak solution of, well, it's called muriatic. It's got a few names, muriatic or even hydrochloric acid, and it's the acid you would put in a pool. And I should have some somewhere. Right, so here are my 2 nickel plates, and we're actually not plating. What I'm doing actually is preparing the solution so that we can do plating. So the plating will happen on another day. So here is my power source. As you can see, I've got voltage here, current there, and it's limited to 2.5 amps, so it'll switch itself off if it tries to draw more. Okay, so what I'll do now is set you back up on the stand, and then I'll mix the vinegar. I've also got a little bit of table salt, and we'll fill this fellow to about 3/4 full. We'll see how much 2 litres fits, and the plates there are basically ready to play. So let's put you back on the stand. Okay, let's get this going. I hope you can see this well enough. There's the plates, here's my vinegar solution, and my little bucket. Okay, so first thing is fill it up to the vinegar. Now there's, as I said, there's a lot of information on YouTube about this. I think that'll do. Okay, it's up to about here. So I put one plate on one side. The polarity is not important because the idea is to just produce a solution. So polarity at this stage is not important. Okay, so it doesn't matter which has positive or negative. So I've got two plates operating. Alright, so let's, before I put the salt in, and then I better have something clean to stir it with. It's already functioning. I've got 7 volts and about 0.14 amps, which is not a lot. So it really just means not a lot's going to happen. Now I can dial the current up, okay, but it's not going to go. Alright, so there. Okay, so it means I desperately need either to increase my voltage. You see the current's coming up. See there, and so is the voltage is coming up, and so is the current. I don't really want to be much higher than, say, 12 volts. Okay, that's at 11.8 with 0.2 amps. If I put the salt solution in, hopefully it's going to start bubbling and produce a decent bit of current as well. So let's just pour that in. Let's stir it. And you see the current going up? It's pulling 1.2 amps at 11.8 volts. Alright, so that was a nice big jump. So that's why, I mean, you can do this with a small battery, you know, provided that you, also a plug, you need DC voltage, it's got to be, and you can plug it in, use the positive negative terminal, and you need, if you're going up to 12 volts, you're going to pull about this on, well, as you can see here, from 2 litres, I haven't got a lot left. And also I'm going to show you in here in a sec, because the action's starting to take. Okay, so again, just stirring up. So I'm happy with that. That's about 11 volts, 11.2. There's a little white thing there, disregard, that's 1.52 amps. Okay, and that's about it. That's about all I want to take out of that. If I up the voltage, the current will go up as well. That's fine there. Now what I'm going to do is lift you up over the bucket so you can see what's going on. Alright, can you see the bubbles there? Okay, so the reaction taking place. Now what's going to happen is those plates should get smaller and smaller and smaller. Okay, and the solution should turn greener and greener and greener. So you need to do this actually in a reasonably well ventilated place. Notwithstanding, all you can smell is the vinegar, but I've got the garage door open and the reaction's taking place. I'm just making sure this doesn't start to jump up any higher than what it is, but that's for me that's good. So if you have a plug-in power pack, 12 volts, read what sort of current rating it has, but if it's 12 volts, chances are on nearly 2 litres of that, and these size plates as well have a lot to do with it, because should I lift one plate out, you should see that current going down. Let me just make sure that you can see that. Okay, yeah, you see that. If you watch that, as I start to lift one out, okay, notice it's reducing. See that? 0.6 of an amp. Okay, so the size matters. Okay, all right. So the size of the plate is critical as well. So as you can see, 1.7 amps at the moment, and I'm going to let that just work its way. What I'll do is I haven't got a timer here, but when I go inside, what I'll do is switch off the camera, that is, and let this just boil away so that our solution can be happy. One last look. And you see that merrily bubbling away. Alright. Now those bubbles, I understand, are toxic. I don't know what sort of gas we're making. I could look it up, but I haven't at this stage. I'm reasonably well ventilated. All I can smell is vinegar, and not a lot of that at the moment. And I've got a relatively clean environment here. And still 11.8 volts, 1.7 nearly amps, and that's good enough. This is now after 1 hour of being switched on, and as you can see, it's starting to turn, well, it's a bluish color, but it'll hopefully start to turn green. So it is starting to build up the nickel in suspension. So, and here the plates, I just pulled them out because I noticed the current was going down, and you can see they've got a film and they're a little bit dirty. So the plan was that I would pull them out slowly, because the sludge on the plates was quite thick, and I didn't want to dislodge it. Take it to a fresh tap, give them a scrub, and let's plug them back in again. So it's going to need a few more hours based on what I see, maybe 2, 3, 4 hours of the same thing. So let's go and clean the plates and see how we look. Okay, so what I've done is clean the plates just in fresh water with a bit of Scotch-Brite type pad, and just reverse them. In other words, the one that was on positive, I've changed to negative, because it was the negative one that was building up the sludge, which is how the transfer occurs. So here we go, fresh plates, just connected up. Let's switch on and see where we're at. Okay, so you can see I'm close to 12 volts and about 1.85 amps, which is pretty good. That's about where we were when we put it in new. And if we look in here, you can see it's starting to bubble. Okay, so what I'll do is just set a little lid over that while I go and do some other things, just loosely, okay, so that the air can ventilate around it, but I don't want anything to drop in it. Well, hi, here we are. I've been making my nickel acetate, and a couple of interesting things. I'll show you the liquid in a minute. There's a couple of ways I've been attacking it, and one is with these nickel welding rods. Okay, I know that they're pure nickel because I've welded and TIG welded with them as well to clean off the flux, and I mean, what you're dealing with is 99% pure nickel. And also I've got these two plates. Okay, now if you have a look there, I've actually let them dry a bit, but they build up contaminant, especially this one here on the negative. Okay, the black negative terminal. So in other words, we're passing from positive to negative, and this becomes a sludge. And I find after about 2 hours of watching the voltage as against the current, the amps, that it starts to diminish, and that's because of the buildup of the muck, I think, or I know, because A couple of times I've, about every 2 hours actually, I've had to pull these out and give them a clean. So we've got clean surfaces, so that again when I plug it in and turn it on, that I'm up to my 2.5 to 2.5 amps. So it does have an effect, so be aware that you do need to clean it. Now this one in particular, the one that'll be on the negative lead, I was a bit worried actually at first because I wasn't sure that it was nickel. Yes, I'd bought it as such, but I was becoming a bit suspicious, so I then tried the 2 welding rods here that I've got, and you can see that they're starting to wear down. You can see that they're coming down to a fine point. So I've just been sticking those across the bucket and wondering if it's going to all come out differently, but it came out the same. So this is a brown sludge, so you need to lift it out carefully about every 2-3 hours perhaps, and then give it a scrub with some fresh water and a little scouring pad, and then reconnect. So I would say that I've done a total of about 14 hours of trying to build up my acetate solution, and so let's have a look and see what we've got. Now, as I said, you need to lift these out carefully because the sludge will separate and it'll fall down to the bottom. So what I've had is two little buckets, so I've got approximately 2 litres of the solution, so I've just been pouring it out, leaving the sludge in and then throwing that little bit out. Okay, so this is my solution here, and it starts off sort of more a light blue. Let me show you. So it starts off more as a light blue solution, and then it becomes darker and darker. So there's about, or if I had to say, probably 12, 13 hours of having the current switched on and the action taking place. So now that is actually saturated with nickel, and so I'm ready to go to the next phase. So I'll just switch back on the stand for a moment. So again, I've got the solution, I've got nickel in suspension, and this is now ready to go. Alright, so our calculations are something like this. It's the book says, anywhere on eBay it says, anywhere on the net it says, if you look it up, you get about 40 amps per square foot. Okay, so I've got one of these little fellows here is about, if I look at both sides, so if I say it's 3 inches long by 1/2 inch wide, okay, now I'm doing both sides, surface area, so essentially I've got about 3 square inches in each of these, give or take. Alright, so 1 square foot is 144 square inches. Okay, one of these, okay, if you measure 3 inches by 1/2 inch, 1.5 square inches, double it both sides, 3 square inches. So if I go 144 square inches, and I need 40 amps for that, then 3 square inches will give me 0.83 amps. Okay, so I guess you need to remember that if I'm doing a single one, it's 0.8, and every time I put one in, I basically increase that by roughly 1 amp. So I've got, in the 3 of these units, if I do them all at once, I've got about 2.4, you know, 0.8 times 3, you know, 2.4 amps of current. So and you don't really want to be any higher than that, because it just things go a bit wild and woolly if you introduce too much current. Now the experts say 40 amps per square foot, then try and stick to that, and it's just, you know, near enough is probably good enough. So now that's ready for the next stage. So I think that's all that I need to explain for the moment. The next phase of this will be the setup, and I might use more clean these up, polish them up, and I've got my solution ready to go. And where you can, you want to be as to have the positive terminal, which will be all these fellows. These will be on the negative terminal, okay, but for the positive terminal you want to sort of be around the circumference of the bucket as much as you can, because then you're attacking it from all sides. If you're only, say, got them you know, facing each other, then it's just going that way and there's nothing coming behind.